Hey guys, welcome back. So today we are going to see how to design a production grade Kubernetes cluster. Okay, so let's get started. So the first prerequisite is a cloud account. As you know, most of the organizations are moving towards cloud. Most of them have already migrated, or else 90% of the companies they are already moving towards cloud. Okay, so we should have any of the cloud accounts like AWS, GCP, Azure in case if someone is using Oracle or some other thing. So whichever it is, so we should have a cloud account, and then in case if they are having some on-prem, that is also fine. Okay, and we have to decide whether it has to be like a managed service, or we deploy the Kubernetes cluster and manage it. Okay, that is also a key thing. Okay, so in case if it is some cloud provider, then we will have like EKS, Elastic Kubernetes service, and GKE from GCP, and AKS, Azure Kubernetes service from Azure. In case if it is on-prem, then we can use kubeadm or Spray, so that we will be able to create the Kubernetes cluster. Okay, and the recommendation is to use any of the managed service, so that in case if there are some issues from the Kubernetes end, that will be managed. Okay, just we can configure our applications and manage the nodes. The main applications and master nodes will be managed by the cloud provider. Okay, so that you will be having less headache compared to them. Okay, you can just take care of the application which is deployed. And also we should have something called Terraform or Cloud CLI installed, so that you can design the Kubernetes cluster and deploy it in huge scale. And a few more tools which are required are kubectl. Kubectl is for communicating with the API server of Kubernetes, and we need Helm. In case if we are deploying the applications using Helm chart, we need Helm. And we have this JQ, which is for the JSON query, and we have Git repo. Okay, we can use GitHub, GitLab, or Bitbucket, whichever you Git provider you need. We can use those things. Okay, and as this is the prerequisite, like we should have the cloud account, and then we have to set up the Kubernetes cluster based on the cloud provider, or else in case if you have on-prem, you can use kubeadm or Spray. And then you should have the CLI tools. Okay, we should have Terraform Cloud CLI. Like in case if you are using AWS, you will have AWS CLI, and then you can use Azure tunnels, etc. Also we should have different tools like kubectl, Helm, JQ, and Git repo, so that we will be able to communicate with those tools. Okay, so once these prerequisites are met, then we will have the setup foundational network. Okay, and IAM rules. So what exactly we will configure here? We will configure the VPC, subnets, routes, NAT gateways, security groups, and roles. So this is like one of the key thing. Okay, because we create all the clusters, everything that is fine. Okay, like it has to communicate with each other, right, to be productive. Because if you have each and every cluster isolated, what is the use of that one? The application will be running isolatedly on each and everything, and they will not be able to communicate with each other. Okay, so in case if there is some issue with that particular cluster, it has to just migrate the data to another cluster, or whatever has to be done, everything has to be done over network. Okay, so this networking is one of the key things when it comes to whatever servers or whatever you think, networking is a key thing. Okay, so in networking we have multiple things. So first one is VPC, like virtual private cloud. So here you will be able to define the public subnet and private subnets. So based on that public subnet and private subnet, you will be able to create the VMs, or deploy the nodes, etc., and deploy the applications based on whether it is a public thing or private thing. Okay, and also you have to enable the routes is like how the communication should exactly happen, and what are all the IP address it has to use. And NAT gateway, so NAT gateway, it is for blocking the access and allowing the ports at the VPC level. And security groups, it is for allowing and blocking the access at the VM level. Okay, and then we should have the roles, like what exactly the permission should be given for each and every user. For example, if we are like DevOps engineer, like we should have the admin rights. Okay, in case if there is a developer team, they should not have access for everything. Okay, only they should have access for certain things which is required. Okay, so we have to restrict the access. Like always we should focus on giving the minimum required access to each and every user. Okay, as we are going to design the production grade environment, we should have a VPC with the three availability zone subnets. Okay, and private for nodes, and public load balancer subnets, NAT gateways, route tables, everything has to be configured. So how we can do it? Like we can create a Terraform VPC module to create that one, like with three private subnets, one per availability zone, and 3 public subnets for load balancers. Okay, and also we can configure the NAT gateways and NAT gateways per availability zone for high availability, and also we can create the IAM roles for this EKS cluster role and then EKS node roles with least privilege policy. Least privilege means we have to give permission only which is required. Okay, we shouldn't give the admin access unless it is actually required. Okay, and we have to verify that 3 availability zones are available and subnets are created. Okay, in case if we don't have these availability zones created properly, then in case if there is an issue or in case if something happens with any of the cloud provider or something, then the data will not be able to migrate to the region where the functionality is proper. Okay, also like wrong route tables. Okay, so what exactly will happen with wrong route tables in case if you have not configured the routes properly, then nodes cannot reach internet for image pools. Okay, and then in case if there is some missing IAM policies, cluster remains failed. Okay, next is like provisioning of the Kubernetes control plane. Okay, so it is like managed or self-hosted. In case if it is managed, like the particular cloud provider like AWS, GCP, and Azure, they will manage the control plane. Okay, in case if you have hosted your own cluster, then you have to take care of those things. Okay, you have to take care of all the upgrades, patches, and in case of any issues, you have to handle that one. So most probably, in case if it is like a huge production cluster, then obviously it is better to be a managed one, so that whatever issue happens, the like particular cloud provider will handle those things with respect to the master nodes. Okay, the worker nodes you can create based on your requirement, and you can deploy your applications, and you can take care of all the patching and all the security aspects as well. So create a cluster with any of the provider. In case if you want your self-hosted, you can use kubeadm. So this is the thing which will create the initial admin kube configs. Okay, and why it is required? So cluster is the central control plane. Okay, so managed control planes are recommended for production because they will have the headaches. And how we can create this one? So in case if you are going to create any of the cluster on EKS, you can use EKS CTL. Okay, so this is the CLI tool which is for the EKS. Okay, using this you will be able to create the cluster. Okay, you can just pass in EKSCTL, create cluster, and then name of the cluster, and you can provide the region and zones, and then you can, in case if you have the node group like which has to be attached to this group, you can just give that one, and then like how many nodes you need. If you give this one, like EKSCTL tool will create the EKS cluster, like Kubernetes cluster from AWS. Okay, so once this is done, so we can verify like kubectl get nodes and then kubectl cs for component status, and then you can check the default namespace configurations like which are available there. Okay, so everything is should be available. And the next one is creating node pools. Okay, node pools or node groups. Why is this important? So once the control plane is done, you can create the node pool, like based on your application size and how much configuration is required, you can just create the node pool. Okay, node pool is nothing but it's a like group of nodes which are nodes means VMs combined together so that it can be attached to the control plane. So multiple node pools with labels and taints you will be able to create. So in case if node role is general, okay, for example, if you need certain things on demand, then you can just define node role equal to general. Okay, and then in case if there are some data which has to be run but that is not important and it is not mandatory to run, then you can use spot instances. Okay, so you have to define it with tolerations, and also like in case if like you have like a GPU intensive tasks, then you have to give node role equal to GPU. Okay, so this GPU workloads with GPU drivers so that it will be more faster. Okay, and then node role equal to storage. In case if you need a node which has to be like in IOTs, like it has to be read and writing more, then you can use node role equal to storage. And also why it is required, like separation of workload types and cost optimization. In case if you have to save cost, then you have to define like how the nodes has to be created. Okay, in case if it is general, like it will be always available. Okay, in case if spot, only it will be assigned when it is available. Okay, in case if there is some urgency from the cloud provider, they will take that instance. Okay, in case of GPU workloads, you have to use GPU, and in case if storage intensive workloads, you have to use storage. And also like based on that you have to select the nodes. Okay, and also we have to enforce taints and tolerance in the nodes so that the parts will be placed in particular nodes whenever it is there. Okay, So in case if you have to verify, you can use kubectl get nodes and then show labels, so that it based on the labels which you have given, it will be allocated. And in case if you have to get the details, you have to use kubectl describe node and then node name. Okay. And then installing CNI and baseline network policies. So for this, you can use Calico or Cilium. Also, why it is required? So normally by default, in case if you have to enable the networking between different parts or everything, then actually we have to use any of the network tools. Okay, like you can install them using Helm repo add Cilium and update. It provides the part networking and network policy enforcement. Okay, so in case if you want to enable the communication between the parts or block between them, then you can be able to do it only using this network CLIs. Okay, so you can use any of the CNIs like Calico, Cilium, etc., so that you will be able to define all the policies, like how the communication has to happen within the cluster. Okay, so this is like very critical, because in case if you have to block access to any of the resources or something, you will be able to do this one. Okay, so how you have to uh, define the policy? You can just use the YAML files like API version kind. Here you have to define network policy, and you can just give default deny or default allow. Okay, so based on that, you will be able to define the policies. So in case if you want to check whether those things are defined properly, you can use kubectl get parts and then in the kube system. So by default, it will be there in the kube system um, namespace. Okay, and also the next important thing is installing cert manager. Okay, so this cert manager is one of the key things. Okay, so like it is like automated TLS. So why set manager is required? For example, you have your components and you have to renew the certificate for them to enable the TLS communication. Okay, but in case if you forgot, or like in case if you have like huge number of clusters, it will be a difficult task. Okay, so what you can do, you can use a set manager. So what set manager will do? Set manager will automatically track for that clusters, and automatically it will renew the certificates once it is about to expire. Okay, so based on the conditions which we give, like when before 7 days or before 1 month we have to renew, so based on that, it will automatically renew the certificates. Okay, so it will auto issue and renew the TLS sets for ingress and services. Okay, so how you can do it? So kubectl create namespace set manager, so you can create a, and then you have to add jet stack repo, and then you can install the set manager. Okay, so using the set manager, you can create a YAML file. So it will be automatically monitoring all the clusters, and it will be creating the certificates. Okay, so in case if you have to verify, you can use kubectl get pods, and then you can give the namespace of set manager, so that you will be able to see how it is managing it. And one of the key things which we have to note when we use set manager is that like rate limits. Okay, with the encryption of production, so it has to be used for staging and testing. Okay, and missing ingress class mismatch. Okay, so this is also one of the issues which we will see. So we have to use the correct ingress class name. Okay, so that we will not see those issues. And next one is installing ingress control. Okay, so we can use nginx or cloud load balancers and expose an app. So this is where all the traffic it will be coming into the cluster. Okay, so we have to make sure that it comes through HTTPS, and also like proper hosting and routing paths has to be defined, and TLS termination also needs to be enabled. Okay, so only once the traffic enters the cluster, so the TLS termination should happen. Otherwise, this will continuously have the connection. So we have to make sure these things. Okay, so we have to install ingress. So default and famous one was nginx ingress, and we will have cloud load balancers, like we will have different load balancers from different cloud providers, or we can use those things as well. Okay, so we can define them in the YAML files under the ingress as the kind. So if you see, like same thing like API version kind metadata, and then in the rules we will be defining the path, like it has to be HTTP or HTTPS, and then paths, like which path it has to path go, and then we can define the backend services as well, like where exactly it has to route the traffic, and also like we can define the TLS host, like where exactly it has to come, and what is the secret names, etc. Okay, so all these things we can see it in services, and we will be able to verify whether it is working fine or not. Okay, so once these things are done, okay, so once these things are done, the next thing is like installing the gitops and connecting to git. Okay, so till now what we have seen, so we have done all the prerequisites, we have configured the networking, and then we have created the cluster, we have created the node groups, and then we have also configured the ingress. Okay, so the traffic is coming in, so everything is fine. So application is working fine and it is okay. Now this application will have the new versions deployed, right? For example, if we have like application version 1, next week or after a month we will have version 2. Okay, we have to deploy that into Kubernetes cluster, right? So the best way to deploy the things, manifest files into Kubernetes is using the Argo CD or GitOps tools. We can deploy it using Jenkins as well, but it is very tough to detect the drift in the environment. Okay, so in case if you're using any of the GitOps tools, it will trust Git as the single source of truth, so that whatever changes it is done, it will be reverting back, and we will be able to manage the drift. Okay. So how to install Argo CD and how to use it, like we have seen in the previous classes, you can go through that one. And so we can also use like application set. So in case if you have like multiple clusters, you can use the application set, so that based on the configuration, it will automatically deploy it in the different clusters. Okay, so we can use that one. And then observability and Prometheus. So observability, whenever we talk about observability, we have to talking about Prometheus and Grafana and Alert Manager. So all these things we have seen in the previous video. You can go through that one. So first we have designed the Kubernetes cluster based on a cloud provider, and then we have did all the configurations with respect to networking and everything, and then we have configured the Argo CD to deploy the different versions of the applications. Everything is fine. So what if something goes wrong with that application or with the cluster? How we will get to know? So for that we need observability. This is one of the key things. Why? Because deploying and running the applications, everything is fine. When some issue happens, which comes in hand? So Prometheus and all these monitoring tools are the key things. Okay, so observability is one of the key things nowadays. So how we will be able to configure those things? Like we can just use Helm charts. Okay, Helm charts to add the Prometheus, and then we will be able to deploy all the things like Grafana and Alert Manager. So Grafana is just a visualization tool of this Prometheus metrics which we get, and also we Alert Manager, it is for triggering the alerts. Okay, so we need the observability. So once this is done, we need something called log collection. Why we need log collection? So for now, you have some error and you are fixing it, but you have to find the root cause, right? Like why exactly this has happened. So for example, you forgot to collect the logs, and if the data is gone, then again you have to reproduce the issue which has happened, so it is very difficult. So the things like fluent wait and vector comes in place of this one. Okay, so what it will do, it will collect all the data and it will transfer to ELK or Splunk. Okay, so what will happen, so you will have the data of all the servers in single place. Okay, in case if you have 100 clusters, if you want to check the logs of these things, you have to go into each and every cluster and you have to check. It will be like a tedious task. Okay, so what is the easier way? You can directly check all the clusters in this Splunk. Okay, so Splunk will have all the logs and you will be able to directly check the logs here. Okay, so it will be very easy during any of the production issues, or else in case if you have to do any of the debug, or else if you want to do any of the RCA, then actually this will be like a very handy. Okay, so once this is done, so we have talked about Argo CD, that is for the deployment, and then we have like different types of deployments, right? So in case if you want to do like blue green deployment, canary deployment, or else a rolling update, whatever it is, you can configure them using the service mesh. Okay, so it is for the paged rollout. We can use Linkerd or else Istio, and also like what it is like, it provides mutual TLS. Like it is one of the key things. So it will verify both the client and application, like both are valid or not before enabling the connection. Okay, so that is called the mutual TLS. And telemetry and traffic shaping, like canary, blue green, whatever it is, so those things can be configured using Istio. And retrace, for example, if something happens, it has to retry how many times, so all those things. And circuit breaking, everything can be configured using Istio. Okay, so you can just configure this thing, and then you will be able to um, you will be able to configure all the traffic manager and then routes, everything. Okay, and next important thing is deploying the stateful systems. Okay, so we have stateless applications and stateful applications. Okay, stateless applications are the thing like which doesn't depend on other part. Okay, whereas stateful applications, each pod created will depend on the another pod which is created, so it will be created in a sequential manner. So even if the data is updated or copied or deleted, it will be doing it in a sequential manner. Okay, so some of the things like strimzy for Kafka, Postgres operator, etc., are all stateful applications. Okay, so how you have to use these things? So operators like strimzy manages stateful sets, PVCs, and scaling of data platforms. Okay, and you can just use a separate namespace for that one, and then you can just apply this one. Okay, so you have to make sure these things are created properly in the stateful sets. So the next one is secret management. So everything is fine, but if you are not managing your secret properly, then any of the external user who have access to something, he can do anything he wants. Okay, so managing the secrets is one of the key things. Okay, so why is centralized secrets with rotation, like we have to rotate every 3 months or 1 month, whatever it is, so you can rotate that one, and also you have to audit the logs and access the policies. Okay, so the best one is to use any of the external secret manager, because by default in Kubernetes it will be like base 64 encrypted. It is like not highly secured. Okay, so in case if your secrets has to be highly secured, you have to use any of the vaults or secret manager providers. Okay, like in AWS we have AWS secret manager or else HashiCorp vault, etc. So you can use those things. Okay, by that your secrets will be highly secured. You can just reference those things by creating a service or something. Okay, and next important thing is auto scaling. So you have the application, and then you are deploying the latest versions, and you are managing the secrets, you are configuring the Kubernetes clusters, everything is fine. Okay, but for example, the main thing which every organization is that you should have good customer engagement and everything. Okay, when you have lots of customers, your company will be more profitable, and then you will be able to grow in everything, like company also will grow and you also will grow. Okay, but in case if your clusters which you have handled is not able to handle the traffic, okay, then what will happen? The website will crash, and the end users, they will be disappointed with the clusters. Okay, so what do you have to have? We have to have auto scaling. So we will have HPA, VPA, cluster autoscaler, horizontal pod oscillator, vertical pod oscillator, and then cluster autoscaler. So what exactly it will do? So in case if horizontal pod oscillator means, so it will try to create new pods in case if there is overload. Okay, vertical pod oscillator, it will try to increase the memory or storage of particular pod or node. And cluster autoscaler, for example, if the entire cluster is overloaded, then what exactly we have to do? So we have to add additional nodes. That is called the cluster autoscaler. Okay. So we will have the different component MLs. So we have to apply that one for the metrics, and then create HPA. Okay. So kubectl autoscale deploy, and then you can set the CPU percentage and minimum and maximum number of parts which has to be created. Okay. So you will be able to verify using kubectl get HPA and kubectl get nodes. So using this, you will be able to verify like how the autoscaling is working. Okay, and next one is security controls. Okay, so normally this thing we have to do it in networking, but we have to do it using separate policies like RB policies, part securities, and gatekeepers. Okay, so what we will define the RBAC policies. Okay, for namespaces and for the cluster level or service accounts, and also we have to install the gatekeepers and add policies like whether it has to allow or block certain containers or something, and also we have to enable the part security admissions. Okay, so it will be restricting the all the accesses for the production namespaces. So we have to make sure everything is proper, because we should always try to give the least privileges. Okay, so all these things are fine. The next one is backup and disaster recovery. So this is one of the critical things. Why? So your application is running, you have configured auto scaling, everything is okay, but something happened. Okay, so you have availability zones as well. Okay, that is fine. But let's assume like all the availability zones are gone. That is like very rare. Okay, very rare scenario. But okay, like let's forget of availability zones. For example, if you have not configured the availability zone properly, and something happened and all the data is lost, what will happen? So the it will affect the end users. So how you can fix this one? You can fix that one using this backup and disaster recovery strategy. Okay, so we can use different tools like Velero or snapshots, so that you will be able to recover from that data or else from the snapshots. Okay, so Velero for cluster object backups and snapshot integration for the PVs. Okay, it will protect against the accidental deletion or site recovery. So we can install this Velero, and then we can just take a backup from this, or else we can just take a backup from the snapshots. Okay, so backup and disaster recovery, configuring this one is also a key thing when you design the architecture for the production level Kubernetes cluster. Okay, and all these are okay. Now choice engineering and runbook drills. Okay, so before we deploy it in production, we have to test everything, okay, like a demo, like whether everything is working fine. Like we will have like common incidents like pod crash, node failures, PV loss, etc. Right? So we have to do a demo, or we should have a sample run books configured, so that we have to practice for each and every scenario which will come. Okay, so it is like a drill session for your Kubernetes environment. Okay, so you have to do this mock test as well. For example, if you are configuring the um, auto scaling, you have to check like what is the maximum capacity of load your cluster can handle, and beyond which capacity you have to add HPA, or else you have to add the nodes, etc. Okay, so all these things can be captured using this choice engineering. Okay, so you configured, everything is fine. But let's assume like it is costing a ton of money for you. Then it is waste of implementing everything, right? So another important thing is cost governance and observability for a platform. Okay. So cost governance. So you have to use this FinOps. So this is one of the key and core concepts nowadays. So everyone is moving towards cloud. Okay, that is fine. But how about the cost? In case if it is costing you more than your budget, then you can't afford it, right? So you have to just you have to monitor like which component is using how much resource, or if something is running unwantedly, everything. So you have to like check each and everything, and then you have to configure it in such a way like only the required resources should be running. Okay, and also in case if you have some test staging environments which doesn't need to be run 24/7. Okay, so what you can do, you can just turn off those machines at the night time, or else you can use spot instances wherever it is required. So you can configure different things, okay, so that you will be saving much of the cost. Okay, and also we have cost metrics analyzers in all the cloud providers. Okay, so based on that, you will be able to analyze like which component is using how much resource, and you will be able to fix those things. And next one is day two operations. So till now what we have seen is day one operations. Okay, like when you create a production grade Kubernetes cluster, you will be able to do. Okay, once the production grade Kubernetes cluster is designed, and if you have configured all the monitoring, cost optimization, auto scaling, ingress, Argo CD, everything is configured. Okay, you have a perfect environment. Okay, now you are giving it to the customer. Okay, now you are giving it hand over to the support team. Okay, so they have to take care of everything like upgrade process, daily or weekly maintenance activities, and patching, everything has to be taken care, right? So how they have to do, so what are all the things they have to do, and in case if you are using cluster lifecycle tooling like EKSTL or schedule maintenance window, and automating it is the snapshots, and then verifying the minor version upgrades, all these things should be taken care in the day two operations. Okay, so you have to create the detailed documentation, and you have to share with the administration team. Okay, and observability and SLOs. Okay, so we will have this all these SLIs, SLOs, everything configured once the environment is ready and up. Okay, like what is the maximum time you will have a service being unavailable, or how much time you will take to fix certain thing. All these things will be configured using SLA and SLO. Okay, so this is the one of the key metrics which you have to quote for each and every customer, like how much will be the availability of your application, like mainly like for example, if your company is providing a service, in case if your customer is not able to access the application for 30 minutes or something, then actually the company, your client company, it will sue your company. Like you are not able to provide the service, right? So they will sue you, and you have to pay the fine. Okay, so all these things has to be taken into considerations. So you have to have this SLO SLA, because we will be providing the high availability like 99%, 99.99 or 99.9999%. So each and every time, like the customer will be paying huge amount for every .9 which they are added. Okay, so based on that, you will be able to design that one, and you have to give the proper working environments for your customer. Okay, in case if it is some downtime from any of the cloud provider, then they are going to pay you for the all these SLAs and SLOs. Okay, so you can configure all these Prometheus and alert managers so that you will be notified in case of any issues. Okay, and deliverable and repo. Okay, so you should have the Git repos for each and everything. For example, if you are using Terraform, you should have a Terraform repo, and then Helm charts we should have separate repo, and Argo City app manifest. So we should have separate repo for that, and then we should have all the run books, everything for the Ansible playbooks, and we should be ready in case of anything needs to be deployed. Just a few modifications, and the environment should be up and ready. Okay, so these are all the things like which you have to configure in case if you need a production grade environment to be configured. Okay, so that's it for today, guys. In case if you like, please like and subscribe to the channel. Let's catch up in the next session. Okay, thank you. Bye.